there are two more parts left for the parallel and relation networks. The part 2 and part 3. They are mostly theoretical. So the part 1, what we saw? We are finding out the same basic parameters for the distribution network, which are represented as lambda Pp, RPP, and stands for parallel. And we discussed that various series components can be combined, okay, and then we derive the formula for two components in parallel and three components in parallel. Now things can go further complicated, okay, but we will focus on, we have discussed to focus on only two components in parallel. What we do is simply combine everything else in series and we make two such components in parallel. Now we see what are the various factors that affect these values. What are the various factors that affect these values? The first one is inclusion of scheduled maintenance. Why scheduled maintenance will be written differently? Because scheduled maintenance are not essentially unavailability or unreliability. So this is scheduled maintenance. That is for a particular purpose. A scheduled maintenance outage is an outage that is planned in advance. Okay. This outage is planned in advance and is deferable. It is when there is low demand, it can be delayed. A scheduled maintenance and involve the removal of component or components in order to perform preventive maintenance. So this is basically preventive maintenance. So you need to write down this. The scheduled maintenance is an outage. Scheduled maintenance outage is an outage that is planned in advance. It is deferable and involves the removal of component or components in order to perform preventive maintenance. The scheduled outage is not included in the reliability evaluation of the load point if by this action alone the load point is disturbed. So we don't consider scheduled outage alone as cause of unreliability. Okay. So it should be like you have done a scheduled maintenance, but after you reconnected the power, it fails. Then only you will consider then only we consider the scheduled maintenance as a cause of outage. Only when it is followed by some other event which causes outage. So that's why it says. Consequently, scheduled maintenance of single radial systems or mesh systems, bus bars, are not included. It acknowledges the fact that customers can be notified in advance or alternative arrangements can be made, and therefore the load point outage is deliberate and cannot be considered as a random. So what it simply says? It says, when you say reliability, you are actually focusing on random events which cause outage. Okay. Scheduled maintenance is not a random event. It is, as this is talking about, customers can be notified in advance. This concept leads to the conclusion that scheduled maintenance is simulated only on overlapping event, only sequence maintenance, scheduled maintenance. Only in the sequence maintenance followed by outage. Write down this. Scheduled maintenance is included for reliability evaluation only when it is followed by post outage. Okay, write down that. So first point you wrote that what is scheduled maintenance. Second point you wrote right. Scheduled maintenance is considered for reliability evaluation only when it is followed by a post outage. Okay. But if after the scheduled maintenance is done, everything works fine, we did not include that in the reliability evaluation. Okay. Rewrite this. Okay. Now once you impose schedule maintenance, what are the evaluation techniques? Let's lambda double dash be the maintenance outage rate of component I. Ri double dash the maintenance time, that means outage time as we discussed. So outage time, lambda j is the post outage. See, I is the scheduled maintenance event, whereas j is the event which is followed after the scheduled maintenance. Lambda pm, rpm and qpm is the rate, duration, annual aspect of the load point into forced outages overlapping. Okay. So here we have a scheduled maintenance outage, but there is a forced outage which is followed. It is followed by a forced outage. Okay. And the combined outage is lambda pm, rpm and qpm. Okay. So these are the formula for two components in parallel. We are not going to discuss solve problems on this. We will be theoretical about it. The question comes in the exam, we will be theoretical about it. Okay. What is the question? What is the question? The question can be, what are the various factors? Just like for radial system we discussed. Okay. For mesh systems, what are the various factors that affect the reliability? Okay. For mesh networks. So one such factors is, one is schedule maintenance, inclusion of schedule maintenance. Okay. You will not write the formula, you can write it later. So this is the similar formula to the earlier one we discussed. Okay. And once you compute all this, the overall reliability indices can be obtained using this formula. So you write down only the last one. The overall reliability indices can be obtained by adding the failure rate of the initial system as well as the failure rate due to combined scheduled outage as well as the maintenance. Okay. Just write down this. Just write down this one. The basic for it, indicative remembering. Okay. Because I would ask problem. Second one. The first one was inclusion of scheduled maintenance. The second factor that will impact the base reliability, base inclusion system reliability is the second one. Coordinated and uncoordinated maintenance. Okay. Only factors, coordinated and uncoordinated maintenance. In uncoordinated maintenance policy, each component is removed from the service for a scheduled maintenance quite separately and independently of others. Uncoordinated means separately and independently of others. Whereas in coordinated maintenance policy, component of a given branch is maintained simultaneously. Just indicate it, not write in detail. Can be 2-mark question. Okay. For example, in our example, assuming the bus bars and breakers being 100% reliable and defining branch 1 as that containing the components 1379 and branch 2 containing 24810, the following failure event associated with the component forced outage overlapping branch maintenance outage can be reduced. These are some examples of this coordinated and uncoordinated maintenance. Branch 1 on maintenance. Branch 1 is maintenance, but component 2 forced out. That means both the lines are now failed. Okay. So it will result in outage. Similarly, branch 1 on maintenance, component 4 forced out. Okay. Similarly, branch 2 on maintenance, component 1 and component 2. Why? Because we are considering the bus bars and breakers to be 100% reliable. So only this many. Okay. So this would be longer if we consider breakers and bus bars. This is the second point, coordinated and uncoordinated. Third point, temporary and transient values. Third point that affects the reliability of mesh distribution systems is temporary and transient values. So far, all failures are put together with an overall failure rate and average repair time, which overshadow the significance and effects of the different types of failures. Two particular types of failures that can occur are those that cause. So, what is a temporary failure? Temporary failure is the one that cause damage to the component but can be repaired. Yes, that's a temporary failure. A transient failure which do not damage the component. For example, if lightning strike gives the protection precursor, blows the protection fuse, but does not damage the shorted components. Okay. Circuit system is destroyed by closing the breakers automatically available. So that's a transient failure. In either case, the outer state is relatively small and maybe negligible. Transient force outages are those which are restored by automatic switching, and temporary force outages are those which are restored by manual switching or use. So write down this. So all this, just mention this point. So what is the difference between temporary and transient force? This is the last line you write. And this is the definition of fluid. Because fluid temporary and transient failures. Okay. So this is point number 3. First is inclusion of scheduled maintenance. The second one is coordinated and uncoordinated scheduling. And the third one is temporary and transient failures. Okay, I am reading this. We write the last one. So, how to evaluate for such scheduled maintenance cases? Okay. So, you need to consider two types of such failures. They are known as first order failures and the second order failures. The failure modes of the system are identified either visually or by using minimal parts of memory. This will give failure events of first order, second order, and is required higher orders. So what is the first order event? These are evaluated directly by using the basic techniques. The first three questions that you go, that is 7.1 to 7.3, the board. Okay. And the values of lambda array as the appropriate value weighted out respectively of the transient and temporary outputs. In case of transient failures, the values of RI exist. Repair. There is no repair time, no outage time. No repair time, transient failures. Automatically restored. After the fuse is blown up or the lightning capacitor is blown. Okay. Second order are found using equation 8.1 to 8.3, which are for the parallel system, two component system. I will you that is known in the last class. So these are such events, second order events. These are the equations which can be derived using 8.1 to 8.3. We will not write in detail, only for completion and government. So these are some examples which are not solved but can be solved using those equations. I won't ask these questions. Only for example. So this completes the second part. Okay. Inclusion of scheduled maintenance.